Students, this question was asked in the year 2013. I have wrongly written it. Let us correct it. This was asked in the year 2013. Dimensional formula for angular momentum. Angular momentum, student, written as L, and the formula is mvr. Okay, student. So what will be the dimensional formula for L? L will be dimensions of M and dimensions of V into dimensions of R. Dimensions of mass is capital M square bracket, that of V velocity is Lt minus 1, and that of R is a radius, that is a length. So this becomes M L2 T minus 1, student, or we may write M1 L2 T minus 1. Here option C is correct. But what is angular momentum, student? Angular momentum actually is the analog of linear momentum P in circular motion. And what is P? Momentum of a body is the quantity of motion contained in a body, and the formula is mass times velocity, or mv, student. And what is the analog of mass in circular motion, student? This is I, called moment of inertia. And what is the analog of velocity in angular motion, student? That is omega, angular speed or angular velocity. So the angular momentum has also another formula, I omega. You have already studied in circular motion. And what is moment of inertia, student? The formula for moment of inertia, I, is mk square, where mass m is the mass of the rigid body and k is the radius of gyration. This is also a length. Okay, student, radius of gyration. This is the formula for moment of inertia. And omega, omega is equal to the angular distance traveled per unit time, or theta by t, and theta is dimensionless, student, m0, l0, t0, because theta is L by r, that is the ratio of two lengths. Theta is arc by radius. So theta is dimensionless and divided by t, student, that is becomes the angular speed h, or angular velocity, has dimensions m0, l0 due to the power minus 1. And so angular momentum will have the dimensions of I into the dimensions of omega. And what is I? That is mk square. We write it here, mk square into omega. What is the dimension of omega? That is t to the power minus 1. And this is m L2 t to the power minus 1. So student, we here also we get the same dimensional formula L2 t minus 1, which we had earlier obtained from the formula mvr. It does not matter from which formula you go, L is equal to mvr or L is equal to I omega, you will get the same result, L2 t minus 1, which is the same as that of the Planck's constant, student.